Alright guys, welcome to this page of the notes, and what we're going to do is we're going to use the information that we just learned about angle bisectors to solve some problems here. What I've done is I've given you a few diagrams, and obviously there are unknown values in the diagrams. We need to figure those out. So here we go, we're going to jump right into it using the angle bisector theorems to go ahead and find these unknown values. Great, let's take a look at the first one and figure out what we're told. Well, what we're told from the diagram, just looking at it right away, you should quickly recognize that these two smaller angles are congruent. That's what those little congruent symbols in there mean. These two angles are congruent to each other. Well, based on the theorems that we just talked about on the previous page of the notes, what if these two angles are congruent? What does that tell you about these two segments, CB and DB? Well, according to the theorem, we know that CB must be congruent to DB. These two segments have to be congruent. That's what the theorem says. Well, if they're congruent, that means that they're equal. So set them equal to each other. 6y minus 16 must be equal to 4y plus 6. Again, how did I know that? The diagram tells me that these two angles are congruent. That means that AB is an angle bisector. If it's an angle bisector, according to the theorem, these two segments must be congruent. You gotta know the theorem and you gotta know what the theorem means. So that's what we get. Well, this is now a really pretty simple algebra problem. We're just gonna solve for y. We will subtract 4y to the other side. It's a positive 4y, subtract to the other side. Negative 16, add it to the other side. 6 plus 16. We wind up with 2y is equal to 22. Oh, look at that. So y will be equal to 11. All right, let's go ahead and find these unknown links. What did I ask you to do here? Find the missing value in each of the diagrams below. Okay, so I get that y is equal to 11. Let's go ahead and find the length of each of those sides. So we'll start with CB. I know that CB is equal to 6y minus 16. I know that y is 11, so let's go ahead and drop that in there. So CB has to be 6 times 11 minus 16. Fairly simple arithmetic, but feel free to use a calculator, don't fat finger something, and you should wind up with 50. Now here's what's interesting, right? These two sides are congruent. So if CB is 50, what is DB? It has to be the same. They're congruent, so DB is also 50. All right. Anyway, that's how these work. Let's go ahead and do another one. All right, in this diagram, look at that, right? Exactly the opposite, right? Just look at it. It takes you 2 seconds to recognize. I told you that these two links are congruent. That's what those little hash marks mean. Well, the theorem says if these two links are congruent, then what do you know about the angles? They also must be congruent. They have to be congruent. So I know that angle JKL has to be congruent to angle LKM. That's what the theorem tells me. These two links are congruent, then the angles must be congruent because KL is a perpendicular bisector, right? As long as you know the theorem, you can immediately pull that information out of the problem. Well, if those two angles are congruent, that means you just set them equal to each other. 2x plus 1 is equal to 3x minus 9. Okay, great. Well, here we go. Another pretty simple algebra problem. We need to solve for x. I'll subtract 2x to this side. I have a minus 9. I'll add it to the other side. So 1 plus 9 is equal to 3x minus 2x, which means x is equal to 10. Well, I got x is equal to 10, but I want to know what is the actual measure of those angles. We can do that. Angle JKL is equal to 2x plus 1. Let's go ahead and drop that 10 in there. 2 times 10 plus 1, which means angle JKL angle JKL is equal to 21 degrees, right? 21 degrees, but I know that these two angles are congruent. It's a it's an angle bisector, so that means that angle LKM is also 21 degrees. Hey, let's keep going. Got a couple more for you here. Hopefully you should be able at this point to do these ones on your own. Go ahead and give them a shot, see what you get, come back and check with me. Right away we recognize, hey, I tell you the angles are congruent. This is just like the first one we did. If those angles are congruent, then I know, thanks to the theorem, the sides, right? These lengths must be congruent as well. So, if they're congruent, we set them equal to each other. That means that Vy is congruent to Uy. That means that 2m plus 9 is equal to 5m minus 3. Let's solve an algebra problem. Subtract the 2m, add the 3. 9 plus 3 is equal to 5m minus 2m. That gives me 12 is equal to 3m, and so m is going to have to be 4. M will have to be 4. Let's go ahead and plug that stuff back in. If Vy is equal to 2m plus 9, 2 times 4 plus 9, let's see, Vy, 17. Right? 2 times 4 is 8, 8 and 9, 17. If Vy is that, then Uy, which is congruent, must also be 17. And I got one last one here for you. Again, hopefully you're just at this point checking back. You've already done it on your own. You're just checking back to see. Oh, okay, now this is interesting. I did not tell you that these two sides are congruent using those little hash marks, but you can clearly see that I've given you the link, 2.7, 2.7. Since they're the same, you know that they're congruent, and if those guys are congruent, then you know that the angles must be congruent. So angle GDF has to be congruent to FDH, so set them equal. 6y plus 3, 7y minus 3. All right, here we go. I'll subtract 6y, add 3. So 3 plus 3, 7y minus 6y, which means y is equal to 6. Let's plug that back in. Angle GDF is equal to 6y plus 3. 6 times 6 plus 3, GDF is going to be 39 degrees, right? 6 times 6 is 36. 36 plus 3 would be 39. And that means FDH is also 39 degrees, angle FDH, right? Because these two angles are congruent to each other. I know that because of the theorem. They both have to be 39 degrees. All right, guys, that's the way that those two theorems on angle bisectors are going to work. Again, really important. If you're given that the angles are congruent, then you know that those distances from a point on the angle bisector to the sides of the angle have to be congruent as well. That's what the theorem tells us. The opposite of that, the converse of that, is if you know that the distance from a point on the angle bisector to the sides of the angle are congruent. If I tell you those distances are congruent, then you know that the angles must be congruent because it's an angle bisector. So all you're doing is simply taking the information given to you in the problem and applying those two theorems, whichever one is the one that you need, in order to set up your algebra problem, which you can then solve to find your unknowns. What we'll do on the next page of the notes now is start our discussion on incenter. I didn't forget about it. The incenter is a point of concurrency of angle bisectors. So now that we've spent some time talking about angle bisectors, we'll go back to that point of concurrency, and I'll see you guys on the next page of the notes.